Continuing our study on factoring, we're now going to get into factoring special products. At the end of this lesson, you'll be able to factor a perfect squares binomial. All right, first of all, I'm just going to tell what a perfect squares binomial looks like, and then some just different key characteristics, and then how we can factor it. All right, the first thing that I'm going to be looking for, if something is a difference of two squares, we are going to look for the function being a binomial. So it has to be a binomial. It actually has to be a quadratic, hopefully. Usually it's a quadratic binomial. And there will be a minus sign in the problem. And I'm going to get rid of this third step. What we're going to be putting instead of that one, we are going to be you're able to find the square root of a number. So we'll have 36, we'll have 49, we'll have 81, because we can take the square roots of those numbers. So those are kind of the key characteristics that we're going to be having as we do these problems. And before we get into factoring, I'm just going to show some examples. If I had x squared minus 36, if you recall when we started the factoring unit, I had you graph that, and if you were to graph that, this is what that would look like, something like that. And since this hits the x-axis at 6 and negative 6, the way that this actually would be factored would be x plus 6 and x minus 6. If you recall, we always did the opposite. Okay, then if I had another one, x squared minus 49, and I were to graph this, it's going to hit at 7. Actually hits at negative 7, so it's going to look something like that. So if I were to actually ask you to factor it by graphing, you would take the opposites of where it hits. So it's going to hit at x plus 7 times x minus 7. Okay, if we did x squared minus 4, if you were to graph it, this is what it would look like graphed. And then notice, since it's hitting at 2 and negative 2, the way that this would factor would be x plus 2 times x minus 2. So hopefully you're seeing a pattern there. If you look, the square root of 36 is 6. One is plus 6, one is minus 6. The square root of 49 is 7. This factors into x plus 7, x minus 7. When this was 4, the square root of 4 is 2. So we have x plus 2 times x minus 2. So there's definitely a pattern when we have the difference of two squares. And notice in each of these, there was a minus sign, and we could take the square root of each of those numbers. So that's exactly what we're going to be doing when we start factoring. So if I have x squared minus 81, since this fits the pattern, there's a subtraction sign. I can actually square root both parts. It's a quadratic binomial, and I can square root the 81. The way that this is going to factor, we notice they both still get that x, and then the square root of 81 is 9. So we get plus 9 and minus 9. And that's what that problem looks like factored. If I have 9x squared minus 25, this one's going to be a little bit different. There's a subtraction sign. It is a quadratic binomial, and I can actually square root the 9, and I can square root the 25. So if I square root the 9, I will get 3x and 3x. And if I square root the 25, I'll get 5 and 5. And I know 1 is always a plus, and 1 is always a minus. And if you were not sure, if you were to multiply that all back out using your arrows or your boxes, you would get 9x squared minus 25. Right, let's try the third one, 81a squared minus 100. When we do this, there is a subtraction sign. It is a quadratic binomial, and I can square root both numbers. So since I can square root both numbers, the square root of 81 will be 9a and 9a. The square root of 100 is 10 and 10, and one gets a plus and one gets a minus. And again, if I were to multiply that out, I would get what I started with. And then the last one, x squared plus 36. Notice there's not a plus sign right here. There's not a minus sign. So this method cannot be followed. And actually, if I were to graph this, this is what x squared plus 36 looks like. And notice it does not hit the x-axis at all. So this one actually cannot be factored. And I do have one more. If I had something that looked like this, x squared minus 15. Notice this time there is a minus sign. We do have a quadratic binomial, but you cannot square root the 15 nicely. So this one also would be a cannot be factored problem. There we go. Okay, so hopefully now you can factor special products.